In this problem, you're going to be expected to factor by taking out the greatest common factor. So, in order to make this problem not look so difficult, let's just take it one thing at a time. Let's find the greatest common factor in numbers, then in y's, and then in v's. Out of the numbers 65, 20, and 30, the common factor that they have is the number 5. Now let's look at the y's. Y to the 9th, y to the 30th, and y to the 18th. The greatest common factor here is actually the smallest exponent. So they have at least 9 y's in common. With the variable v, we have v to the 18th, v to the 20th, and v to the 4th power. The most that they can have in common is actually the smallest one, which is v to the 4th. Now that we know what our greatest common factor is, it's time to divide each term by the greatest common factor in order to find out what is going to go inside my parentheses. So again, let's take it one thing at a time. The first term, 65 divided by 5 gives me 5 goes into 6 one time with a remainder of 1. 5 goes into 15 3 times. Y to the 9th divided by y to the 9th is simply 1, so we don't have to write that. And v to the 18th divided by v to the 4th leaves it with v to the 14th. And that's going to be our, let's look at the second one. 20 divided by 5 gives me a positive 4. Y to the 30 divided by y to the 9, if you follow your laws of exponents, you should subtract, and 30 minus 9 leaves me with 21, so that's y to the 21. And then v to the 20th power divided by v to the 4th power, you subtract, so 20 minus 4 gives me v to the 15th power. Now let's look at the third term. Here we have 30 divided by 5, which gives me a positive 6. Y to the 18th divided by y to the 9th. Again, subtract, so 18 minus 9 leaves me with 9. And then v to the 4th divided by v to the 4th. If you subtract that, you get v to the 0. Anything to the 0 power is 1. I don't have to write that because 1 times 6y9 is going to give me 6y9. So this is going to be my final answer.